everyone, welcome to Vedantu JEE English. I am Diksha, your chemistry master teacher. And students, today we are going to start hydrocarbons. So everybody, do let me know in the chat box if you are ready to start this new chapter. And in this week, I am going to finish this chapter. Next week, we are going to do haloalkanes, haloarenes, and similarly, every week we'll do one chapter. And that's how by the end of October, we'll complete our syllabus. Right? Okay, yes, everybody, do let me know if that is clear. Shall we start? Shall we start, everyone? Yes, Rama, Raju, Krik, Malai, Ujjwal, yes. What you're trying to say? Thank you so much, Rama, Raju. Thank you so much. Vanakam, Vanakam, Namaskaram, Namaskaram. So, ma'am, GOC notes, oh my god, what do I do with that? I'm little Sharminda today, too much. Okay, I'll do that, yeah, I'll do that. See, too many things going on in my life, right? Okay, now let's not talk about notes, I'll do that, okay, I promise you I'll do that, right? I promise you, let's not get into that now. Okay, so yes, everybody. So how many of you are from class 11th and class 12? Do let me know in the chat box. Right, so accordingly, I'll pursue this. And guys, beyond NCERT, we will do, right, hydrocarbons. We will not, our organic chemistry is not limited to NCERT, right? There are so many things, right, we need to think about. For example, Wood's reaction. I don't know how you have studied Wood's reaction till now, but in today's class, you will see Wood's reaction from a totally different perspective, and this is what we want to see, right? Okay, this is what we want to talk about. We'll do a lot of practice questions, PYQs, everything, right? And before that, guys, our offer of test series, a Clavia test series has been extended, right? So, what you need to do, it is just at the 999 at this point, right? But anytime this offer can end, right? But because you guys were still thinking that, ma'am, okay, yes, ma'am, we need 1 or 2 days more to convince our parents, you can do that and purchase this, because here, guys, like really good topic wise, part syllabus, full syllabus tests have been specially made from the previous 20 years, right? Previous 20 years of every single attempt JEE mains question paper. You will not see PYQs, you will see questions that are around the PYQs, like from analyzing now what new they can ask, right? Or within the PYQ also what else they can ask from that PYQ, right? So that is what you need at this point. Full practice, everything just at 999 at this point, but otherwise the price is, I think 6,000 is the price here, but right now it is at 999, okay? Yes. So, how long is this lecture? See, I am going to end this lecture. This lecture can be 1.5 hours, it can be 2 hours, it can be 3 hours. Even I have no idea about it, right? Why? Usually, I think it will take around 2 hours. I think after 2 hours, it will be done only. But tomorrow, I am going to take a long lecture, because tomorrow you guys have holiday, right? So, tomorrow I am going to take a big lecture, right? That means it will be around, like let's say 3 to 4 hours, right? I'll set the time, I'll talk to Namrata ma'am and Shreyas sir on this if they have their sessions tomorrow. Otherwise, I can also take the session in the evening. That also we can do, right? So, we'll think about that, right? But in today's lecture, till we have completed alkanes, preparation, properties, chemical properties, we'll do that. Because that is a major part of today's lecture. So let me wear specs because eyes are really straining. I know you guys don't like me that much in specs, but what to do, I have to wear it, right? Guys, I'm blind that way, right? So now firstly, what are hydrocarbons? That means which has hydrogen and carbon, those kind of organic compounds. Nothing else we'll talk about, right? Just hydrogen and carbon. So they are divided into two parts. One is aliphatic, that is acyclic, right? Then there are cyclic compounds, right? Aliphatic, acyclic, that means open chain, right? And this is what we are going to talk about. This cyclic will be our last part, that is lecture number 3 will be of cyclic, that is aromatic, non-aromatic, anti-aromatic. This though we have already done how to calculate this, but the reactions of aromatic, non-aromatic, anti-aromatic, heterocyclic compounds, right? All these we'll talk about in lecture 3, okay? All these we'll talk about in lecture 3. In today's lecture, we'll talk about aliphatic, acyclic, that means open chain compounds which has hydrogen and carbon. And in this you have two categories, one is saturated, other is unsaturated, guys. Saturated, S for saturated, S for single bond, okay? S for saturated, S for single bond. So in saturated you will have single bond, right? There is no pi bond that is involved here, right? But when we talk about unsaturated, we talk about alkenes, alkynes, that is double bond, triple bonds, okay? This is what we want to talk about, right? Now if you see this here, in alkanes, you will have single bond, right? This will have double bond and this will have triple bond, right? Alkane, alkene, alkyne. What is that? Alkane, alkene, alkyne. And today we are going to talk about alkanes. Okay, today our topic is going to be for alkanes. Right, everybody? Now, let's understand this more. Right? Full topic is alkane. What is the general formula of alkane? That is CnH2n plus 2. That is for alkane. Now, this you have studied in lower classes as well, right? This is alkene and this is alkyne, right? The general formula of alkene is CnH2n. Of alkyne is CnH2n minus 2, right? That means, let's say if you have C4H8. Now, is this alkene, is this alkene, is this alkyne? You will just see that this is 4, this is multiplied by 2. That means here we are talking about alkene, right? If you have C4H10, that means they are talking about, most probably they are talking about alkane. Acha, one more thing. Alkene and cycloalkane. Cycloalkane also have the same formula, right? So when I talk about C4H8, right, it can be a cycloalkene, cyclobutane, or it can be a butane. Both things can happen here. So this is overall scenario when we talk about alkane, alkene or alkyne. Because today's lecture is entirely based on alkane, so we'll focus on this thing, that is CnH2n plus 2, that is our formula, right? Now, if you discuss the nomenclatures of butane, N-butane, isobutane, this all I have already told you, so I am just recapping, right? Those who are like, ma'am, please teach us nomenclature in detail, right? That I'll not teach here. I have already taught you nomenclature in detail. Yes, if there is some different kind of structures, names are there, then definitely I'll teach you in that particular functional group. But because I have taught you all of this, so I'll just recap this so that you can revise things in a fast manner, okay? So we'll just recap this. If you talk about N-butane, N-butane is when you have a normal chain. There is no branching here. When we talk about isobutane, what is an isobutane? When you have one carbon which is connected to two methyl groups, right? That particular group is called as iso. So do we have that group? Yes. You have a carbon which is connected to two methyl group. This is one CH3, this is another CH3. So when you have one carbon which is connected to two methyl groups, that becomes your iso group. And in total 1, 2, 3, 4 carbons you have. So that means there we are talking about isobutane. Okay, isobutane. Next, guys, similarly we have N-pentane, isopentane, neopentane, right? N-pentane is normal, there is no branching here, In N you have no branching. In iso, what I told you, you will have a group where one carbon is connected to two methyl groups. I am not saying one carbon is connected to two more carbons. I am saying one carbon is connected to two methyl groups, right? So if you see this here, this particular carbon here is connected to two methyl groups. One is this, right? This carbon here, in the similar way we have written, this is connected to two methyl groups. So that means it is iso group. This is your iso group. And iso, how many carbons you have in total? 1, 2, 3, 4, 5. So it will be regarded as isopentene, right? IUPAC naming is quite simple, right? So I am not getting into that. That's why I am teaching you again N-iso and neo, right? Now, neo, what I told you. Neo, guys, what I told you. What is N-neo? Neo. Neo is not tertiary. Neo means you have a carbon which is connected to 4 carbons, but out of that 3 will be methyl, okay? You have a carbon which is connected to 4 carbons, right? But out of that 3 are methyl. 1, 2, 3, these 3 are methyl. This is methyl here, but even if it is not methyl, even then it will be neo, right? So neo is a group when you have 3 methyl groups connected to a carbon, right? And 1 more carbon is connected, right? So that is your neo, and this is 5 carbon, so it is pentane. So I'll just wait a minute. I'll just write here what is N, what is iso, what is neo. Everybody, what is N? N defines no branching. N means no branching will be there. It is a single with no branching, single chain it is, right? Then we talk about what is iso. Iso means you will have this kind of compound where 2 methyl groups will be connected. If you have this kind of thing, then you can say that this is your iso group. Talking about neo, we'll say you should have 4 carbons definitely connected to it. Out of this, 3 should be methyl, right? Next, we don't know what is this. This can be methyl, this cannot be methyl, doesn't matter, right? But here 2 methyl should be connected iso, here 3 methyl, but 1 more carbon also, because then you think that, ma'am, this is 1 carbon, ma'am, is this group also? If you say, ma'am, is this group also neo? 1, 2, 3, yes. Tell me, can I say this group is neo? Everybody tell me, can I say this group is neo or not? Everybody in the chat box. Yes, Garishma, N-iso, yes, yes. Now Garishma, tell me, Ujjwal, Chris. Okay, yes. JEE Aspirants, Abhinav, very good, very good. Manish, yes. You say not in NCERT. Yeah, that will not be in NCERT, beta. GOC, what I taught you, na, that is beyond NCERT. In NCERT, very limited portion of GOC is given to you, right? You have to go beyond it. No, right? This is not neo. This is not neo, guys. Neo means you should have 4 carbons connected to it. Neo-butane does not exist only. It exists from neopentane. That is the reason here we have not written neo-butane. We have not made this kind of structure, because neo is defined by scientists that neo is that thing in which a carbon which has 3 methyl groups and 1 more carbon is connected. So here 1 more hydrogen is connected here. If it was carbon, then it would have been pentane, right? But this is hydrogen, so it is butane, and this is not at all neo, right? This is not at all neo, right? Okay, is that clear, everybody? Is that clear, right? Okay, yes. So now let's talk about nomenclature, right? Iso have this already. Iso have 2 methyl groups attached to second carbon. Neo have 3 methyl groups attached to the second carbon, out of which there should be 1 more carbon that is connected. Okay, these 2 points I have already told you, right? Okay, so now if you see this here, right, isoheptane, right? So that means you will subtract 1 from it, This will be 6. That means 6 should be the chain here, 6 chain here, right? And this group is iso. If you see, this group is iso. 1 carbon connected to 1 methyl, 2 methyl. Total how many carbons you have? 1, 2, 3, 4, 5, 6, 7. So it will be isoheptane, right? Next is neoheptane. Now in neoheptane, what you will have? This particular thing is called neo. Where you have not even this actually, this particular thing is called as neo. Where you have a carbon which is connected to 3 methyl groups and 1 more carbon here, right? So it is connected to 4 carbons, out of which 3 are methyl. So that means this is neoheptane. Okay? Understood everybody? Right everybody? Easiest in the whole GOC? Yes. So if you talk about this one here, tell me, is this iso, neo or what? Just tell me that. Is there any iso group here? Is there any iso group here or not? Is there any iso, ma'am? Bromination and chlorination you will do in this chapter or other? I'll do in this chapter only. That selectivity, reactivity principle I think you're talking about, right? We'll do that in this chapter. In fact, today only we'll do that, right? Okay, yes. So this is your iso group here, right? IUPAC naming you can do yourself also. What I wanted to tell you is iso group here, right? IUPAC naming bacha you can do yourself also. What is the maximum number? 1, 2, 3, 4, 5. So this will be 1, 2, 3, 4, 5. Third and fourth position, or if you do the numbering from, oh God, if you do the numbering from this side, 1, 2, 3, 4 and 5, so on second and third position you have methyl, so 2, 3 dimethyl pentane. Okay, simple nomenclature it is having, right? Now let's talk about what I wanted to explain you in detail is N, neo and iso. Right, nomenclature we have done before also. In fact, I also did N, neo and iso before also, but I just recapped it for those students who have not watched that lecture, right? Now we will be talking about the preparation. Now the reactions is going to start. Okay guys, there is one more concept here, that is conformers of alkene, right? That we have discussed where guys? We have already discussed conformers of alkenes, right? We have already discussed the isomers of alkenes, right? In isomerism, right? If there is some chiral carbon, it can show optical isomerism. That is already we have discussed. So that's why conformers of alkane, isomers of alkanes, I have already done that, right? So that we only focus on the reaction part, right? That's why I took so much time to complete GOC, right? Okay, yes. So today, thank you, Ram Charan, Jay Ujjwal, very good. Okay, now let's start with preparation of alkenes. Let's see that guys. So I'm just not going to show you the reactions. You will see something really amazing here, but for that you have to have full patience here, right? So let's start from, firstly from alkenes, how it is done. So here in the alkenes, you will have a double bond. Now tell me, if you have a double bond, right? That means you will have one sigma and one pi bond here. You want to convert it into alkane. That means you will have to break the pi bond, and attach hydrogens into it. That means you will have to do hydrogenation. You will have to add hydrogens, right? There can be so many methods of doing hydrogenations, and here we are talking about catalytic hydrogenation. This is called as catalytic hydrogenation. So guys, in catalytic hydrogenation, what you will see that here you have no so what is the mechanism? I will tell you. Basically this catalytic hydrogenations is like, okay, let's see, this is the surface, okay? You know the concept of adsorption. So this is the catalyst surface. So what exactly catalytic hydrogenation, what happens here? You will have alkane here, and hydrogen will also means they will show the reaction on the surface of this particular catalyst, right? And that's how a 4-member transition state will be formed. Let me just show you that how it is done, right? So what you will have a surface, let's say this is the surface of the catalyst, okay? So you will have, let's say, C double bond C, okay? I'm not drawing the other things here, right? And here what you will have on the surface, you will have H also. Now what you will see here, this is H2, this is C double bond C. There can be other hydrogens. If you want to write, you can write here, right? This can be, if you want to write CH here, this is H and this is R, you can write this here. Now I am saying that this is the surface of the catalyst, okay? This is the surface of the catalyst. Now see what is going to happen, how 4-member transition state will be formed. Now what will happen, guys, this particular bond will shift here, right? This bond will shift here, right? And meanwhile what you will have, this particular bond will break because it has shifted here, right? This bond will break and this will attach here, this will attach here, and this particular bond is shifted here. So what will happen, this bond will also break, right? And this will attach here. Now can you see, okay, so I'll just show you, I just showed you the product here, okay. This thing is happening. Now I'll show you with white pen what are the bonds that are getting formed. This is the bond that we will form, this is the bond that we will form, this is the bond that will break, this is the bond that will break, okay. So this is your 4-member transition state. This is your 4-member transition state. It happens at the surface of the catalyst. No intermediate is formed here. It is an exothermic reaction. Energy is released in this process, right? So what will happen after this? This bond will eventually break and this bond will eventually break, and eventually in the end what you will have, formation of this bond, and hence you will have the formation of RCH2H2. And that's how alkane is formed here, right? Okay guys, and that's how alkane is formed here. Got it? So I can also, I'll just, this bond was already there. There was also, with white I am showing some bonds that were there. These are the 2 bonds that were there that are not there right now. Okay, so that's how with 4-member transition state you will have the formation of the compound. Now next is Sabatier-Sanderson reaction. It's a naming reaction in which we talk about that alkene and alkyne. You have alkene with double bond, you have alkyne with triple bond, right? Now double bond is converted to alkane, triple bond is converted to alkane. What exactly we are doing here, right? What is the exact thing that we are doing here? Double bond is converted to single bond, triple bond is converted to single bond, but here some specific temperature is required. This is around 200 degree and this is around 300 degrees Celsius, right? Even if we have double bond or triple bond, what we need to do, just add hydrogen into it, right? And alkene will be converted to alkane. For alkyne conversion, you need a slightly higher temperature. So this is one of the simplest naming reactions that you have, that is Sabatier-Sanderson's reaction. Okay, the catalyst, if I say nickel is the catalyst here, right? 200 to 300 degrees Celsius we have. At 200 alkene will be converted, at 300 alkyne will be converted to alkane, right? And guys, if you instead of nickel, you use Rene's nickel, right, which is a kind of alloy that you have. If you use Rene's nickel, in that case, at room temperature only, this reaction will take place. You don't need to give it so much temperature if you use Rene's nickel here, right? Okay, everybody, that is clear, students, that is clear. But with Rene's nickel, nothing is required. Now, usually you will see from here. Now next, what is next, है ना? If I teach you till here, you'll be like, and you see this kind of question in the exam, right? Then you will be very disappointed, right? Isn't it? So that's why these questions is what we will discuss today, right? This is what make your concepts very clear, right? So guys, if you see this 4 moles of H2, nickel, platinum, palladium. So these are the different catalysts that you can use. Here we are saying that 4 moles you have. How many pi bonds? See, one thing is 1 pi bond require 1 H2, right? So how many pi bonds? 1, this is 2, this is 3, this is 4. So 4 pi bond means that the formation will be 1, 2, 3 and all of them will be converted to single bond and you will have the formation of this compound here, right? Okay, yes. Now, interesting thing is they are saying you have only 1 mole of hydrogen. Now the confusion is, ma'am, I have 2 categories of pi bonds. Ma'am, 1 pi bond is alkene. 2 pi bonds are alkene, 2 pi bonds are alkyne. Now, which will be hydrogenated faster? So, in this kind of situation, alkyne will be hydrogenated. It is preferred over alkene. So, what is the answer that we'll have here? The answer will be this double bond will stay as it is. This double bond will stay as it is because no 1 mole you have, right? Either it can choose this pi bond or this pi bond. So, it will choose this pi bond and here 1 pi bond is connected to 2 pi bonds we had here. 1 pi bond will break and you will have a double bond here as well, right? And that's how you will have your answer, okay? So, always remember, right, that alkyne is hydrogenated, it has faster as compared to alkene, right? Okay, everybody. Next is transfer hydrogenation. So, what is transfer hydrogenation, right? Wait a minute, it should be double bond. So, sometimes now we don't need hydrogen from outside. Sometimes we don't need hydrogen from outside. We can, without having any hydrogen, we can have hydrogenation reaction. Let's see how. So, here what will happen? This particular, here you will have 2 hydrogens, here you will have 2 hydrogens. So, transfer hydrogen means what will happen? This 1 hydrogen from here and 1 hydrogen from here will be eliminated and hence there will be formation of a double bond here. Hence, there will be formation of a double bond here. And how you will see that? Double bond, double bond, double bond, right? And in this case, these 2 hydrogens that are eliminated will be attached here, breaking this pi bond, right? And hence you will have the formation of, hence you will have the formation of CH3, okay? This is what you will have here. Tell me, guys. Achha, now you will think that, ma'am, but what is the need, ma'am? You're just saying that this reaction will happen without any reagent. Without anything, this reaction will happen. Yes. Why? Because this is a non-aromatic compound, if you see. There is no complete conjugation here. It is not planar. This is sp3, this is sp3. Right? It is not planar. No complete conjugation is there. So, it is non-aromatic. And this particular compound is benzene, which we know is aromatic in nature. So, can you see this compound is aromatic? So, non-aromatic to aromatic is the driving force for this reaction, that if I give my 2 hydrogen here, this will be converted to alkene and I will be converted to benzene. That's why it is so happy that I want to be aromatic. Okay, right? Tell me, everybody. JEE, I can complete 11 syllabus on time. And if I start now, Madhuri, dekho, what I can say, right? If you give your 100% even now and you have good basic knowledge, watch the one shots. I am going to complete the syllabus in a month. right? Then watch my previous lectures also, which I have already done, right? So strategy really matters and your hard work really matters now, right? Like you really need to like go beyond your limits if you want to like start from now, right? Okay, so yes, so that is clear to everybody. That is called transfer hydrogenation. Hydrogen is being transferred from one compound to the other compound, right? Next is 1,4 addition, and this is very important, and based on this they ask you the questions. Okay, this is very important. That is 1,4 addition. So now let's understand 1,4 addition, guys. Let's understand. Yes, right? So let's talk about this here. In this case, guys, what will happen? 1, 2, 3, 4. So what exactly will happen now? When you give hydrogen into it, the product that is formed will be very weird. You will have the answer as this. Double bond, this is CH3, hydrogens are added here, this is H, this is H. So can you see this remains CH, this remains CH, here you have a double bond. Here on this position and on this position hydrogen is added. That means it is 1,4 addition. But ma'am, why it is so? Why 1,4 addition is happening here? Why it is so? Okay, let's understand that why it is so. Okay, let's understand. I think firstly you are able to understand that what exactly is the question, what exactly is happening, what's so abnormal that is happening that we have to do it, right? Like separately we have to do this. It has a proper name, 1,4 addition. Because according to this, either hydrogen should be added here or it should be added here. The answer should be CH3, CH2, CH double bond CH2. This should be the answer. But in reality, the answer is 1,4 addition. So that is something very weird, right? That should not happen. But now we have to find out why this is happening, why 1,4 addition is happening, right? So let's understand this concept, right? Let's write it like this. This is CH. This is CH, right? This is double bond, this is CH2, this is double bond, this is CH2. This is H and this is H, and you will see a cyclic product formation. A cyclic product will be formed, a cyclic intermediate will be formed, right? A cyclic intermediate will be formed here, and what kind of intermediate that is? This bond is going to shift here. This bond will shift here and this bond will shift here. When this H2, the bond will break, it will shift here, this will shift here, this will shift here. And you will have the formation of, if you see this here, this is CH2, the nuclei I am going to write as it is, this is CH. Now I will show you the bonds that are breaking, right? This is CH2, this is H and this is H, right? And bonds that are getting formed, okay? So with red, I will show you the bonds that are breaking. So this is the bond that is breaking. This is the bond that is breaking. Okay? That is breaking. So bonds that are getting formed here is, this bond is also breaking. This bond is also breaking. With blue, I am showing you the bonds that are intact. Nothing is happening there. With red, I am showing the bonds that are breaking. And with white, I am showing you the bonds that are getting formed. Here new bond is getting formed and here new bond is getting formed, right? A cyclic structure is formed here, right? And eventually this bond will break this bond. Red bonds are breaking, no. So what will happen? Eventually what you will have, this is CH double bond, this will be formed here, CH, and this will be CH2H, and this will be CH2H. Can you see 1,4 addition? Can you see 1,4 addition? 1, 2, 3, 4. Right? Here 1, 2, 3, 4. Right? 1 and 4th position you have added the hydrogen here. Right? Okay. Right? Tell me. Is that clear how it is happening? Is that clear? So a cyclic intermediate is formed because of which 1,4, because of the shifting of the double bond, because of a conjugation here, there is shifting of a double bond because of delocalization, and hence you will have the cyclic intermediate, which will further lead you to have 1,4 addition, right? Okay, everybody, do let me know, right? Do let me know if that is clear. Now let's see this particular reaction that is given to you. Now here they have added D2, right? So this D2 will be added on first and fourth position, right? So that will be CH2, single bond CH, double bond CH, CH2, because double bond will be shifted here, right? And here you will have deuterium that will be added. Here you will have deuterium that will be added, and this is going to be your final product. Okay, this is going to be your final product, that is 1,4 addition product. 1,4 addition product. Addition product. 1,4 addition product. Okay, yes, everybody. When you will finish syllabus so that I can act accordingly. Abhishek, this month I will complete this syllabus. Don't worry about that. By the end of this month, syllabus will be finished. P block maybe will be only left with P block by the end of this. Yes. Then by the end of this, everything else I will do like thermodynamics. Then we are left with equilibrium, chemical ionic equilibrium. Organic, so I think within 2-3 weeks we will be done with that. So don't worry about that, right? Okay. So 1,4 addition product, guys, we have, right? Now this is a very, very important thing. Okay. Now let's focus here. This is throughout your organic chemistry. This is very important, right? Okay. Yes, I wish I could, but I can't, right? So if you see this here, this is a very, 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 very important thing throughout your organic chemistry, right? I'll tell you in what ways you will do that, okay? So firstly, let's understand this, right? See, what is syn addition and what is anti-addition? Syn addition is when you have a pi bond, when you break this pi bond, one is hydrogen is added here, hydrogen is added here, that is syn addition. Anti-addition is when you have a pi bond, you break this pi bond and one hydrogen is added here, one hydrogen is added here. That is called as trans addition, or means you can just say that, in syn addition it is coming from the same side. In anti-addition it is coming from the nucleophile or electrophile, whatever is the attacking reagent, that is coming from back side. Okay, that is anti-addition. And in every reaction, especially in alkenes, especially what I am saying, in alkenes especially you will see, right? Because in alkenes, especially the properties of alkenes, right? When we will study chemical properties of alkenes, you will have the syn addition also, anti-addition product. So many products will be there. Syn anti-addition product will be there. That we'll discuss in the next class. So syn addition, anti-addition you will have, and that will be different for every single reaction. Okay, that I will tell you in every single reaction, whether it's syn addition or anti-addition. That you have to learn from the mechanisms, right? Now, if you see cis we have done in geometrical isomerism. Cis means when this is the double bond, and when you have cis means two same on same side. Trans means same on the opposite side. Now see, whenever you will do the properties of alkenes, when you will study, right? Because today, in one reaction we will study this today, but tomorrow we will study it in so many reactions. You will have a double bond, right? Some reaction will happen there. Now two things, either this can be cis or trans, or the reaction can be syn or anti. So whether your product is erythro or thereo, ma'am, have we discussed this? Yes. Erythro means same side. Erythro means whether your product will be like chlorine, chlorine same side, or it will be chlorine, chlorine opposite side. What kind of product will be there, right? So whether it will be erythro or thereo, that depends upon what you have, right? You have cis or trans or syn or anti. So a simple thing to do that is, firstly you will see if both are same, then it will be erythro. That means, let's say cis is positive, syn is positive. This is just a way to remember. Let's say cis is positive, syn is positive. Let's say trans is negative, anti is negative, right? When you have positive, positive, negative, negative, overall it will become positive. That means it will be erythro. That means B. That means the addition that you're doing here, that will be on the same side, okay? And thereo means if you have positive, negative, that means you have cis and anti addition. You have trans and syn addition. That is your thereo product will be formed in that case. If you have cis and you have syn addition, you have trans and you have anti addition, then erythro product will be formed here. Now let's do an example to understand this concept better. And if today you are finding it difficult, tomorrow you will find it very easy, because we'll do multiple reactions based on in the chemical properties of alkene, right? Because today we are talking about hydrogenation, so that's what I thought that today little bit you should know. Now guys, can you see this here? Can you tell me, can you see this here? This is syn addition. Is this like hydrogen is coming from this side, this hydrogen is coming from this side? Isn't both are coming from the same side? Same side addition of hydrogen is there. So can I say this is actually syn addition? This is actually syn addition product. So syn addition will be there, right? That means here we have syn addition. Okay, yes everybody, do let me know. Guys, don't spam, right? Don't spam, okay? Otherwise what I have to do na, I'll just have to block you. Nothing else I can do, right? I can only block you, and this is what I'll do, right? So let's see, we have syn addition. Now tell me, is that clear how we have syn addition, right? How we have syn addition. Okay, syn addition is there, that is cool. Syn addition is there, that is cool, right? In every way we are doing syn addition. See, same side we are adding, from same side we are adding. Now when you're adding D2 here, that means in catalytic hydrogenation, syn addition we do, because that happens on the surface of the catalyst, right? And from that 4-membered intermediate, we can see that syn addition is happening here. We'll see so many reactions where anti-addition will be there, but today we are not talking about that. Today we have a reaction where syn addition is there. So two things can happen. Either the alkene can be cis or the alkene can be trans. Now these are the kind of questions that you should know if you want to solve questions of JEE Mains, JEE Advanced. These are the basics that you should know, right? So this is cis. Cis plus syn. This is also positive, this is also positive. That means erythro product will be formed. To this carbon you have the attachment of one CH3. And one hydrogen is there, one CH3 and one hydrogen, and you have added deuterium. So deuterium should be on the same side, because erythro product is formed. Erythro product is formed here, right? Okay. So what we are saying, erythro product is formed here. Okay, now tell me one thing. You have trans, that is negative, you have syn, that is positive. Positive and negative will form thereo or will form erythro, right? Will form thereo, ma'am, without catalyst syn addition possible? No. With catalyst syn addition. With catalyst I am talking about, that syn addition is there, right? I am talking about with catalyst on the surface of catalyst, right? Okay, yes. But I am again repeating this for those students who are finding it tough to understand. Guys, see, alkene can be of two types, okay? This is the type of alkene that you can have. Actually, we are looking for the stereochemistry of the product that is formed after hydrogenation, right? whether it will be thereo product or it will be erythro product. Now, if you're confused that, ma'am, what is thereo, what is erythro? Thereo means you have, let's say you have added deuterium. Now, deuterium is added on the same side, that is thereo. If deuterium is added on the opposite side, that is, sorry, this is thereo, this is erythro. This is erythro, okay? They're added on the same side or opposite side, right? This is how we write it. Now, if you have cis alkene and syn addition is there, it will form plus and plus will form erythro. If you have cis and anti addition is there. Now, in hydrogenation reaction, anti addition does not happen. There are so many halogenation. There is in hydro, when you add hydrogen, syn addition is there. In halogenation, when we will do chemical properties of alkenes, we will study about halogenation. In halogenation, when you add halogen, anti-addition is there. Understood? Similarly, so many reactions we will discuss. But today we are discussing only hydrogenation, which is syn addition. Okay, that is syn addition because it is happening on the surface of the catalyst. Okay, it is syn addition. So, if your alkene is cis and syn addition is there, so it will form erythro. If your alkene is trans and syn addition is there, that means plus minus, that will form thereo. So what I am telling you, you don't have to remember all of these things. Just remember two type of alkene, cis and trans, two type of addition, syn and anti, right? Name cis as positive, syn as positive, this as negative, this as negative. When the combination is positive, positive or negative, negative, it is erythro. When the combination is positive, negative, negative, positive, it is called as thereo. Okay, right? Same sign, same side, what you have to remember? Same sign, same sign, same side. Same side. Okay, that means thereo. That means erythro. Okay, is that clear? Right? Now, if you see this, this is a trans product, this is syn. Opposite sign means opposite will be there. So, when you add it, this will be CH3 because this is carbon, here it is connected CH3 and CH3. So, this carbon, let's say I want to write it 1, 2, 3, 4. So, this 2 carbon, second and third carbon, one CH3 is there, one CH3 is here. So, I am writing it CH3. You can write the numbering 1, 2, 3, 4. On second and third position, you have the addition of deuterium. But this will have thereo product. Thereo product will be formed. That means deuterium will be opposite to each other. Right? Rest of the things will be same. Okay? Tell me guys, here also we have added deuterium, so I will just add it like this, and here it is erythro. And here what is formed? Thereo is formed. You can write it here how? This is syn plus cis. This is trans plus syn. That means, right, here the products will be like that. Okay. Yes, everybody, do let me know if that is clear. Right, this is positive here, this is, yes, this is negative and this is positive. Right, okay. Yes, everybody, chalo. Such shameless people we have here now, what to tell? Devil is actually a devil, na? Shameless people, stupid, shameless, as if some people behave like as if they don't have any mother, right? They are born out of some, other universe only, right? They don't respect women like even a bit. Please God protect every female that is around them. Please God protect those females who think that they are good people and treat them as their friends and have faith on them. Just protect them. And yes, I am very far away, very distant, so I am safe, but just protect every single female who is around that person who has this garbage in his head, right? Just protect them, right? Already it's not that safe out there for women, right? Okay, so third is, guys, I hope so now this is clear, right? Everybody do let me know. because it's a very, very important concept, right, that we have just learned, right? Okay. Yeah, that too in Navratri, huh? That too, they are talking about all this shit in Navratri. I am not saying that I am a goddess. I am not saying that. But guys, have some respect. In Navratri, where we are like, today is Navami, right? Navratri, it's a celebration, right, of womanhood, right? We celebrate that. And we actually do, like, we pray in front of all Devis, right? So, I'm not saying I'm goddess, but maybe some little ansh of that goddess is in me, right? So, respect that. Very sad, very like, God bless these kids out there, like, really. Okay, so that is done, everybody. Clear, right? Okay, yes, done, right? Perfect. Okay, so now let's talk about third, that is from alkyl halides, right? From alkyl halides, guys, now things are going to be little bit easy, right? Alkyl halides, that means you have halogen attached to the alkyl halides, guys, means that you have, let's say, CH4. When you replace one hydrogen with halogen, that becomes alkyl halide, okay? So in alkyl halide, when you have nascent oxygen, you give, nascent oxygen means you are giving just one hydrogen here, right? Nascent oxygen you are giving. In that case, this X is replaced by a hydrogen here, and you will have the formation of alkane. Then from the reduction also it happens. Either you give directly nascent oxygen by some method, or by the reduction. Now that reduction can be done in various ways. You can give it zinc plus HCl, zinc plus CHECOH, zinc copper couple in ethanol, then red phosphorus plus HI, then aluminium plus mercury, ethanol. These are all good reducing agents that are going to convert this Rx. You use any of these reagents, you can convert Rx directly to RH by using any of reducing agents. By using any of reducing agents that are mentioned here, that is called as reduction. Okay? Yes, everybody. Now specifically let's talk about reduction, red phosphorus and HI. So what exactly happens? In this case, what we do is, this Ri, when it is reacted with HI, what happens here? This is a reversible reaction. If you don't use red phosphorus here, it is a reversible reaction. Okay? So when you use red phosphorus, the I2 eliminated here is not giving back reaction. Rather, it is consumed by phosphorus to give Pi3. Okay? So, what we know, that the reaction of Ri with HI, the reaction of Ri with HI is a reversible reaction. What we know, guys, the reaction of Ri with HI is a reversible reaction. You have Ri with HI, it is a reversible reaction. It will go forward here, right? And after that, what will happen? Reverse reaction will take place. Here you will have RH plus I2. This will be formed. This is a reducing agent. If you are not using red phosphorus, then this reaction is going to reverse. If not using red phosphorus, this reaction is reversible. But because now we are using red phosphorus here, so what is going to happen? This I2 that is there, this will be consumed by red phosphorus and it will give Pi3. So further, the more amount of I2 is formed, that is converted to Pi3. That is the reason we use red phosphorus here. Okay? Right, everybody? Tell me if that is clear. Deepak, that we'll talk about in aldehyde ketones and carboxylic acid. Okay, if I, that will confuse you more, right? We'll talk about these reducing agents again and again. Okay, Crick, is that clear? Tell me. So now from alkyl halides, let's talk about the reduction in case of zinc, right? We talked about zinc, so many reductions of zinc, right? So let's talk about zinc HCl. This also we have talked about what happens, right? So in zinc HCl, what exactly happens? Let's talk about that. In zinc HCl, zinc will lose 2 electrons, right? And what will happen once it loses 2 electrons, here you will have Rx. These 2 electrons will attack on the electron deficient R group here. Now C and X, this is electronegative, this is electropositive. So electrons will attack on this carbon here, not on the halogen, because it is already electron rich. So it will attack here, and hence this bond will break, this will shift here, and hence you will have the formation of X negative and R negative here. So once you have X negative, what will happen? You will have HCl there. So this process will always be there. See bacha, whenever you have zinc here, zinc here, zinc here, right? In all these cases, right? Zinc is, even in aluminium, right? So in all these cases, what will happen? This R negative will be formed. That means carbanion is going to form, right? So after carbanion, right now we are saying HCl, it may be some other way where you are giving H positive. That H positive will be attached to the R negative, you will have the formation of the product, right? And in the end, the byproduct will be formed accordingly, like here you have Cl and Zn2 positive, they will combine to form ZnCl2. Right? But the major task here is that carbanion is formed here. This is what you need to know. These are the things that are important for you to know, that in this case carbanion is formed. Just remember that carbanion is formed. Okay, that will define everything here. Right? Okay, yes. Most of the catalysts here are acid. If you see CH3, copper couple in ethanol, all these Hg, ethanol, all these are acidic in nature. They will give H positive to the carbanion that you have formed here. And that's how the work of all these reactions will happen. Guys, tell me, is that clear? Is that clear to everybody or not? Is that clear? This, right? Okay. Now let's talk about Wood's reaction. Now guys, let's talk about Wood's reaction, one of the most important reactions, right? I know you are like, ma'am, please, it's quite easy, ma'am, please, ma'am, relax, ma'am, okay? Ma'am, this they will ask us, ma'am. Let's see how they will ask you this, okay? Let's see, we'll move towards the difficult questions, or not difficult, they are also easy, but yes, some interesting questions of Wood's reaction. So first we have to understand what is Wood's reaction. Wood's reaction, what we have? We have alkyl halides, right? You react it with sodium in the presence of dry ether, right? You will have RR combined and you will have the formation of an alkane, that is double the number of carbons you have in the alkyl group, right? Okay, that is called as Wood's reaction. Now the question is, ma'am, why dry ether is used, ma'am? What's the need of dry ether, ma'am? Let's talk about that. So why dry ether is used here? The reason is that sodium is electron deficient. So ether is used as lone pairs which facilitates more solubility of sodium in ether. Right? So this is sodium, Na positive. So what exactly will happen? I'll also show you the reaction here, what will happen. Sodium will actually what will happen? Sodium, guys, sodium has 11 atomic number. It has 1s2, 2s2, 2p6, 3s1. 11 electron it has. Now what will happen? It will lose 1 electron to get converted to a noble gas. Configuration 1s2, 2s2, 2p6, right? So that means sodium is going to lose one electron to become sodium positive. Now this sodium positive that you have here, right? And here you will have ether. To make this particular sodium soluble, we have added ether. Okay? We want to make the sodium soluble, we have added ether. Right? To increase the solubility of sodium, we have added ether. Okay? So this is what is written. Lone pair which facilitates more solubility of sodium in the ether because of this kind of structure that it has formed. Ether also releases more solvation energy. Because of more ethers around it, more solubility is there, more solvation energy is there, and the reaction will be easy, right? Now, next question is, ma'am, we are using ether, but why dry ether? Why not moist ether? Because sodium is very explosive in nature. Dry ether is used, sodium is very reactive towards moisture, so that is why we have to avoid moisture here. So that is why dry ether is used here, right? Okay, yes everybody, where Cl negative is there, where? Cl negative, guys, Cl negative is there, yes, definitely. This is +2, this is minus. Halogen is negative, most electronegative, so it will always pull out the electron pair towards itself, right? So this is the reason that we are using dry ether. Now we know that down the group, this is RCl, this is RF, this is RBr, this is Ri. This bond is very difficult to break, so this now will never use. Fluorine is already very explosive, so in most of the reaction we will not even talk about fluorines, right? We will talk about mostly chlorine and bromines only. Now what exactly happens? We know that down the group, chlorine, bromine, iodine, down the group size increases. So that is why bond length increases. That is the reason if you talk about RCl, this is RBr, I am just drawing it so that you remember it this way. You can see bond length is increasing, so more the bond length, it is easy to break that bond. So that is why we can say Ri has the highest reactivity, then RBr, then you will have RCl. Okay, that is the reason this is a reactivity order here. Where is C negative? Where is C negative? Where I am saying C is negative? Nowhere I am saying C is negative. Right? Where I have told you? Halogen I was talking about. Right? So Wood's reaction, let's talk about some other things here. Only symmetrical or even number of alkanes are formed in high yield, right? Because R is getting converted to RR. So always it will be double. So it will always be double. Now ma'am, but ma'am we have to combine it. Ma'am let's use, one more thing here, let me just, this thing I'll do here, okay. Let's talk about this. Now when I talk about that, ma'am why odd number cannot be prepared? Ma'am if we use CH3 and CH3CH2, ma'am this alkyl and this alkyl group should combine together to give us CH3, CH2, CH3. But this exactly does not happen, right? So what is happening here? This CH3 can form, CH3 with CH3 can form CH3, CH, because there are infinite number of CH3Cl molecule, infinite number of CH3CH2Cl molecule. So firstly, one molecule of this will combine with itself to give you CH3CH3. One molecule of this will combine with itself to give you CH3, CH2, CH2 butane. And then maybe one molecule also will combine with each other and give you CH3, CH2, CH3. So it's not like odd number cannot be formed. But what exactly happens here? A mixture of product is formed. Mixture of product is formed. And because of this mixture of products, what happens? It is very difficult to separate. Difficult to separate. So we cannot find individually a pure propane here. So that is the reason this method is not used in the formation of odd number of alkanes, right? So that is why we use this thing. Only symmetrical or even number of alkanes are formed in the high yield. So that's why always propane odd number cannot be prepared, because mixture of products are made. Now methane is not formed because at least two carbons in product. The lowest that you can use is CH3, Cl, and that will also give you CH3. So methane is never possible here, right? Next guys, if you talk about ethane, what you will do, how to prepare ethane? Simple, CH3Cl, CH3Cl, they two will combine together, right? And they will give you CH3, that is ethane is formed here, right? Okay. Now guys, let's talk about the mechanism here, right? Wait a minute. Yes. Achha, one more thing. There are some important parts here. For example, you have a acidic hydrogen, if acidic proton is present, we know that sodium is already converted to sodium positive by losing one electron. That it is already doing. We know this step. It is already doing that. So you have Na positive now. So if acidic proton is there, that means if you have an acidic proton here, what it will do, it will, rather than saying, well, this is the acidic proton that you have, this particular proton is the acidic proton. So if acidic proton is there, what it will do, it will replace this. It will be CH2ONA, right? And this is CH2Cl. So what you were thinking that what you will do here, you will like Woods reaction will take place and you know RR will be formed. But in reality, it's not like you have to give like, okay, teach the reaction, hey, you have to behave like this. No, reaction will behave according to the reactants that is there, according to the conditions that you have. Now because this is alcoholic OH which is acidic in nature, that is the reason this H positive it will lose and it will form a salt here, right? So acidic proton should not be there. Okay, yes, very good Abhishek. Less yield, yes. Okay, now tell me guys one thing. PYQs, beta, I'll take a different session of PYQ, okay? PYQ, don't worry, I'll take a different session only. Acha. Now before going further, no, I want to teach you. Wait a minute. Okay. Wait a minute, guys. Wait a minute. Oof. What to do? Just give me a second. I need extra page here. Okay. Yes. This I'll just write here. Wait a minute. I want to teach you, before going further now, I want to teach you the free radical mechanism. So what I'll do, I'll just again write it. This is ONA. Acha, what is the mechanism that is followed by Woods reaction? What is the mechanism, everybody? What is the mechanism? Anyone? What is the mechanism? Is it a free radical mechanism? Is it a free radical mechanism, guys? Yes. So let's talk about the mechanism. So actually it's a free radical mechanism. What will happen? Firstly, you will have sodium. Sodium will be Na positive plus 1 electron, and this is what you will have. You will have Rx. So we know that this is partially negative, this is partially positive, but still what will happen, this homolytic cleavage will take place and one electron will shift here, one electron will shift here, and hence you will have the formation of R free radical and this X free radical. Now what will happen, this electron is going to attack here and you will have the formation of X negative, and this is R free radical and R free radical with combine, it will give you RR, right, and X negative plus NaCl will combine, Na positive will combine and give you NaX. That is how the products are formed. Okay, understood? So it follows a free radical mechanism. It follows a free radical mechanism. Free radical mechanism, right? Free radical mechanism is followed in this case, right everybody? Okay, do let me know if that is clear or not. A free radical mechanism is formed here, right? Okay. So now let's see, by free radical mechanism, always in the answers will have to apply that, think about free radical, and there are so many applications of it. Okay, let's understand the applications here. So whatever you want to make the product, always remember that what will happen, firstly make a free radical here. This will, one homolytic cleavage. Homolytic cleavage means, what is homolytic? Guys, one is heterolytic. Let's say this is C, this is X. Heterolytic cleavage means both the electrons are shifting here. This becomes C positive, this becomes X negative. Homolytic cleavage means one electron is shifting here, one electron is shifting here. This is C free radical, this is X free radical, right? And free radical mechanism is what followed by the Woods reaction. Okay, so here you will have 1, 2 carbon, this free radical here, right? And two free radicals will combine together to form RR. So similarly you will have another free radical here. So what you will have in the end, this carbon will get attached with this carbon. Total 4 you will have here. You can also draw it like this. Wait, this free radical. Okay, so these two will join together to make a bond. So 1, 2, 3, 4 carbon alkane is formed in the end, right? That will be your answer, right? Okay, yes, yes Ramcharan, you are right, you are right. Okay, yes. So now let's talk about this one, right? Same Woods reaction we are doing. Free radical is what you have to make here. Make the free radical. This will be CH3, this is CH, this is CH3, right? CH3, and this is free radical. So two molecules of this will combine together to give you CH3. CH will join together with another CH, right? This is the free radical joining that you have here, right? This bond, right? And this is another molecule, CH, CH3, and you have CH3. And that is the alkane that is formed here from the free radical. Okay, yes. Now let's talk about, this is not intramolecular, wait a minute. Till now we have not discussed that, right? Achha. Now let's talk about this one. Next is, here what kind of free radical it can give you? The free radical that it will give you is this free radical. So 2 moles of it will join together to give you, this is the compound, a double bond, a single bond here. This is the compound, a double bond here. So actually what you had here, you will have one free radical here, one free radical, and they will join together to give you this compound, right? Okay, understood everybody? Yes Ramcharan, you are right, you are right. Okay, tell me, is that clear? It's like you can make a eye here, smile here, eye here, smile here, right? This is how imagination works, right? Okay, now let's talk about some molecules where intramolecular is also possible. Let's talk about that. Let's talk about that everybody. where intramolecular is also a possibility. Let's talk about that. Intra is preferred over inter unless the intra product is highly unstable. Ma'am, what do you mean by this? Let's understand this with the help of an example. Here, two halogens. So this is usually in case of, this is a case of dihalides. When you have dihalides, then this can take place, right? So when you have a dihalide, that means two halogens you have, the free radical will be CH2, 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 a free radical here and a free radical here, right? Because two homolytic cleavage can happen, this case and this case, right? This is fish hook arrow, okay? Two homolytic cleavages are possible. Now, in this case, two possibilities are there, right? Two possibilities are there, right? One is inter, other is intra. Only in dihalides you will have this kind of possibility. In case of inter, what can happen? Inter means between two molecules. So, two molecules will combine together. This is CH2, this is CH2. This is another molecule, CH2, CH2, CH2. Here you will have free radical that will join, here you will have free radical that will join. 1, 2, 3, 4, 5, cyclohexane is formed. Or intra is possible, that means this will join with this free radical. So what you will have, CH2, CH2 and CH2, right? Now, which one is preferred? That is the question. Which one is preferred? That is the question. So, what I told you here, yes. What I told you, whenever there is a confusion is whether intra we should prefer or inter is preferred over inter. This unstable we'll talk about. Unstable means unless intra product is anti-aromatic. If this intra product is, and because anti-aromatic is the most unstable compound. If intra product is anti-aromatic, only then inter will be preferred. Otherwise, intra is always preferred. So here will not prefer inter, will prefer intra. So this will not be the correct answer. This will not be the correct answer. This is going to be the correct answer here. So answer will be intra. This is the correct answer here. Right, everybody? Okay. Is that clear? Ramcharan, I understand, but pinacolone rearrangement I'll teach you in aldehydes, right? Not here. Right? Okay. Chalo. Intramolecular, now let's talk about this one. Firstly, all you have to do is make the free radical. Make the free radical. This is 1, 2. This is free radical. Always firstly solve intra. Intra means within the molecule, and within the molecule the answer will be, these two will join, and this is already a very stable compound. So intra is preferred. Intra is preferred. A very stable aromatic compound is formed. Right? So intra is preferred here. Let's talk about the next one. Here you have this Br and any of the Br over here. Make a free radical of dihalides, right? This is the compound. These are questions, right, which are very, very interesting, right? This is Br, this is a free radical, this is a Br, this is a free radical. So join these two, make the intra product, Is the intra product anti-aromatic? Is the intra product anti-aromatic? No. Even if it is not aromatic, it's okay. It is non-aromatic, it's fine. It should not be anti-aromatic. If it is anti-aromatic, then you will say intra, inter I'll talk about, but here intra you will prefer. Okay. Next is this compound. Now this is a very, very, very important question. Mark it very, 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 very important. So very, very important question. Let's see that. Let's talk about this and let's see how you're going to define it. Okay. Okay, everybody. Yes. I don't know why my studio is always showing some other time zone. I am so done correcting this. Okay. So here what you will have, this is one bond, this is a free radical, this is a free radical. Firstly, make the intra product. What is the intra product? You connect them, this one. Now can you tell me, is this intra product aromatic or anti-aromatic? Anyone who can tell me, is this anti-aromatic, right? It's okay, no issues, Ramcharan. Yes, tell me. So here what we will do, this is 1, 2, 3, 4 pi electrons. This is anti-aromatic. Anti-aromatic, when this is anti-aromatic, so definitely this will not be formed. This product is not formed and we will choose inter here. We will choose inter here. So inter will be, you have this one, right? You have this and you have another. These are two free radicals, these are two free radicals, and that's how they will combine to give us a compound which is not anti-aromatic. This is all we want, right? So answer will be, this is the correct answer and you will choose this, not this. Okay, so this is the answer. This is the answer. Okay, everybody, right? Is that clear? Any problem? Any problem? Ma'am, why we remove all BR? See, second B, all BR, because it will not choose, right? It will not choose. This will not choose that, okay, this BR or that BR. If it is dihalide, it will make free radical from those two, replacing those two halogens. It will definitely do that. Okay? Tell me. Any problem, beta? Any problem here? Any problem, students? Why double bond left side or why double bond left side on left ring? Oops, I'm sorry. It should not be left side. Wait a minute. Thank you, thank you, thank you for correcting. Yes. It should not be here. It will be here. Yes. You are correct. It is here. That's how free radical here and free radical will connect. Very good, Abhishek. Very good, very good, very good. Yes. Good, Abhishek. Ma'am, is that, but anti-aromatic if it is, we don't want a very stable compound. It should not be a very unstable compound, right? Anti-aromatic is so unstable that no one wants to get converted to anti-aromatic, and here we are getting anti-aromatic compound. That's why I have to choose inter, otherwise I'll always choose intra. But I'll have to choose inter if there is anti-aromatic compound that is formed, okay? Okay, I hope so that is clear now, right? Okay, now let's talk about disproportionation reaction of Wood's reaction. Sometimes it also shows disproportionation. Let's see how. Okay, so what it will do, homolytic cleavage will take place here in the place of sodium and everything will be there. This is CH3, this is CH2 free radical and this is X free radical. Okay, now what will happen to this particular CH3, CH2 free radical? What can happen here? What can happen here? This can also be CH2, CH2 free radical. This is one of the possibility. We are not saying this will happen. This is one of the possibilities that can happen. So this can shift here, this can, because reaction is not like it is written in exam. Reaction is not, these chemicals are not writing an exam that they have to follow a particular thing, right? If this is one of the possibility, that is, right? So then this will be converted to CH2 free radical, CH2 free radical, that will be further converted to, CH2 double bond CH2, okay? And here And here what we will have, another possibility is that you will have CH3, CH2 free radical, right? And here, because when you make this, you will have the formation of one more free radical, that is H. H free radical, CH2, CH2 free radical, okay? So that H free radical can combine here and it can give you the formation of CH3, CH2, CH3 product. So that means what is happening, it is not getting doubled. This product is just getting disproportionated. That means this alkyl halide, one is getting converted to alkane, other is getting converted to alkene, right? So that kind of disproportionation it is showing, okay? This is also one of the possibilities here, right? Okay, yes. Achha Ramchandran, have you texted me on Instagram? If it is so, I'll today check, right? Aldehyde class, guys, it will take 2 weeks. Ramchandran, it will take 2 weeks because this week hydrocarbons and haloalkanes, haloarenes, then alcohol phenols and then aldehyde ketones. It will take time, right? I think I'll teach you pinacol, pinacolone in alcohols only, not aldehyde. I'll teach you in alcohol phenols only. So don't worry. So just 2 weeks you have to wait, okay? Yes. Okay, this we have already done, right? Now let's talk about fatigue reaction, everybody. What is a fatigue reaction? Fatigue reaction is when you have two aryl groups, right? In woods, how you remember this? Woods means alkyl, fatigue means aryl. In fatigue, you will have same reaction, but it will be aryl groups here, right? So when you have an aryl group, a diphenyl or biphenyl is formed here. That is, this kind of free radical will be formed here. That will combine together to give you a diphenyl group here, right? This, just remember that this is one of the compound that is formed, again free. Achha, what about Wood's fatigue reaction? In Wood's fatigue reaction, you will have one alkyl part and one aryl part. Again, from that free radical mechanism, you will have the formation of, again from that free radical mechanism, you will have the formation of a group, that is on benzene you will have a alkyl chain, okay? So this is your Wood's fatigue. So what you have to remember, Woods means alkyl part, fatigue means aryl. This is how I remember. One fatigue means you will have two aryl and biphenyl is formed, and Woods means that you will have two alkyl part, okay? Now next is Franklin reaction. Now we know that in case of Woods reaction, only symmetrical alkanes can be formed, right? In that process also, Franklin reaction in which we used zinc, right? That we do here. So in this case, Rx with Zn with Rx will give you R2Zn, that is called as Franklin reagent. This is one of the organometallic reagent only. This will react with the Rx again and will again give you RR. That means from Rx again you are forming RR. What is important part here? That again symmetrical alkanes are formed here. So again, not that useful and not that asked, okay? Now let's talk about Corey house synthesis. Now this has a very important advantage because here you can form unsymmetrical alkanes with high yield. That is a use of Corey house synthesis where we use Gilman's reagent, right? This is R2CuLi, R2CuLi, that is Gilman's reagent. So what you will have, this is R2CuLi, that let's say this is R-X. So if I write the general reaction, this is R-X plus this is R2CuLi, that is Gilman's reagent. This one is Gilman's reagent, okay? I'll just write it here, R2CuLi, right? This will give you R dash R plus you will have RCU, that means RCU plus LIBR, LIX. This is the general reaction, and here you have the formation of unsymmetrical alkanes are formed here. That is the advantage, right? Okay, that is the advantage here, right everybody? Yes, yeah. We use Zn in Frankland, and Core house synthesis we used copper. Okay. Thank you so much, Abhishek. We'll do that again as well. This year also, I'll do PYQs also in between that, right? So now let's talk about more things here. Let's talk about reducing agents. So we have 3 reducing agents. We'll see how they impact 1 degree, 2 degree and 3 degree. Okay, let's talk about that. 1 degree alkane, 2 degree alkane and 3 degree alkane, how they impact it, right? Okay, in alkane I am saying how they impact 1 degree halide, 2 degree halide and 3 degree halide and 3 degree halide. Now this is a chart that you should remember. LiLH4 in 1 degree, 2 degree will give you alkane, in 3 degree it will give you alkene. NaBH4 has no reaction with 1 degree, 2 degree and 3 degree it will give you alkane. pH phenyl thrice SNH will give you alkane in all the cases. Usually LiLH4 and NaBH4 is asked, okay. So example is here this chlorine is attached to that carbon which is further attached to 3 more carbons. So that means this is a 3 degree alkane. This is a 3 degree alkane. So in a 3 degree alkane, what you have is, you have with the LiLH4, you have the formation of alkene. That means HCl will be eliminated here and you will have the formation of a alkene. How? This Cl from here, let's say here you have H, here you have 2, so this will be eliminated. This bond will shift here and hence you will have the formation of alkene. With NaBH4 it is going to, with 3 degree it is going to give you alkane. That means that chlorine will be replaced by hydrogen and this is what you will have the formation, right? So these are some of the direct reactions that you have, right? Okay, tell me. Clear? Now next is from carboxylic acid, one of the very most important reactions, that is soda lime decarboxylation, and Kolb's electrolysis, again one of the most important reactions here. These two very highly important. Okay, so let's discuss about Kolb's electrolysis and soda lime decarboxylation one by one, right? So in soda lime decarboxylation, what is soda? Soda means caustic soda, that is NaOH. Lime means quick lime, that is CaO, right? So soda lime is used here, NaOH plus CaO is used here, and what you will have decarboxylation means CO2 will be eliminated here, and in this, after replacing all of this, you will have the placement of H here. That means in this RH with 1 carbon less, here you have R plus 1 carbon, here you will have only R number of carbon here, that alkane will be formed. And now let's understand what is the mechanism that it follows and what is the intermediate that it has. So the mechanism that it follows is what you will have, because this is an ion only, so this is actually RCO negative. So if you place it here RCO negative, so what can happen? This particular electron will shift here, right? Because obviously oxygen, or everyone wants to be neutral in the neutral state, so this bond will shift here and this bond will shift here, and hence here you will have the elimination of CO2 from here, and this will be R negative, so R negative is formed here. Now in this R negative, that is your carbon ion intermediate is formed here. This is very, very important, that in case of soda lime decarboxylation, carbon ion is the intermediate, and with this R negative you add H positive and you will have the formation of alkane. That is your mechanism of soda lime decarboxylation. This much is enough, you don't have to get into more detail. This much is enough, that carbon ion is the intermediate here, how it is done. Right, now let's see 2-3 things for this question. So first is, if they ask you that in soda lime decarboxylation you have the formation of butane, what is that carboxylic acid salt from where butane is formed? So here if the number of carbons are n, here it will be n plus 1. So it will be 1, 2, 3, 4, 5. CH3, CH2, 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 COO negative Na. This will give rise to the formation of C4H10, that is butane. Okay? This will give rise to, in the formation NaOH plus CaO, this will give rise to the formation of butane. That means here one carbon should be more, one carbon less alkane is formed here. Right, everybody? Okay. Now let's talk about another question here, that is, wait a minute, that says, for this they are asking the rate of reaction for the following carboxylic acid salts, carboxylic acid in soda lime decarboxylation. Now these are the questions where I was, again, if you remember in GOC I was telling you that sometimes GOC is not asked directly. They will not directly ask you stability of intermediates. Sometimes from these questions they mix two things. First thing, you should know what is soda lime decarboxylation. Second thing is, you should know that it has carbon ion as an intermediate. Then you should know GOC. 3 concepts you should know, right? So one thing is, we should know that carbon ion is the intermediate here. If carbon ion is the intermediate, right? This is A, this is B, this is C. Now you have to select which carbon ion is most stable. That will give maximum. More is the stable intermediate, more fast will be the reaction. You have to tell the stability of the intermediate. If you see, this is Cl, this is CH3 and this is H here. Rest of the things are same. This is taking away the electron, this is giving the electron. So when you are giving the electron to a carbon ion, you are making it very unstable. When you are taking away electron from the carbon ion, electron withdrawing is making it stable. So answer will be A, then B, then C. So answer will be A is maximum stable, then B, then C. But for that you should know GOC, you should know that they will not ask you carbon ion, they will just say soda lime decarboxylation, which is out of this which will react fastest for soda lime decarboxylation. You should know that carbon ion is the intermediate. Okay? Yes, everybody? Okay, your main account this much. Okay, because I am clear with this. Those rearrangement reaction, I have some trouble. Please check. Okay, Ramcharan, I'll do that. Okay? Yes. Yes, everybody. Now tell me, right? So this is how you should know that, how actually things work. Now let me see if you can tell me about this one. Let me see if you can tell me the answer for this one, rate of reaction for this one. Let us see who can tell this. Yes, everybody, and do like the session. Yeah, so many efforts we are putting in just for you guys. Do like the session from the past half an hour and 1 hour. Likes are the constant. Like the session, make it to 50 plus likes right away, guys, right away. Right? Least you can do is like the session. I have to teach you without any break. Right? So, what about this one? A and B, everybody, let's see. Tell ChatGPT to act like human and normal, how low English explanation, sometime using nature things as example. Okay. So tell me, this is negative, this is positive, this is negative. Which one will react faster? Here you are giving the plus I effect you are showing. Here plus I effect is only from the cyclic ring. Here it is from the cyclic ring plus this CH3 here. So definitely this is becoming unstable. Yes, because more electrons, already it is negative, stress it is already there, giving it more stress. So B will be more as compared to A, and that will be the rate of reaction in this particular case. Right? Okay, B is more as compared to A. Now next is Kolb's electrolysis. Again, one of the most important reactions. Kolb electrolysis you will find easy because it is quite similar to Wood's reaction. Okay, the questions will be quite similar. Okay, so let's talk about this. Let's talk about this. Wait. In Kolb's electrolysis, guys, what you have, same thing, RCONA, decarboxylation you are doing, electricity you are passing, cathode, anode, every mechanism also will talk about, right? And you will have here the formation of RR. This is the difference in Kolb's electrolysis and soda lime decarboxylation. In soda lime decarboxylation, RH is formed. This is the R part. In this R is formed. That is a major difference that you should remember. Right? Now, how this actually happens? This happens via free radical mechanism. Free radical mechanism. Let's see how. Even if you remember that it is free radical, but you have to remember now what is formed at cathode anode. For that, I will just show you the mechanism here. Now, how it is done? So, first is sodium acetate. This by electrolysis, what will happen? This is by electrolysis. Wait a minute. At anode, we want to talk about. Okay, this is CH3CO negative. This is the ion here. Okay, this is Na positive. This CH3CO negative. Now, what will happen? One electron will shift here. One electron will shift here. Right? That means this will be converted to CH3CO free radical, right? CH3, because of these electrons you might get confused, but just focus on the free radical, okay? So here it is converted to CH3 C double bond O free radical, right? Then further homolytic cleavage, this will cleave and this here will cleave, right? And here on this carbon you will have already one free radical. Oxygen also has one free radical, so they will join to form carbon dioxide, and this will be CH3 free radical is formed. Two CH3 free radical will combine to form RR. At cathode, what will happen? You will have water which is going to lose one electron, and here it will give you H free radical, which two molecule will combine to give H2, right? Okay. Tell me, do you understood that? So, what is happening here? You have CH3, I will just show you here if you are getting confused by that. This thing you have, okay? This thing you have, so I will just write it on the next page only. If you have CH3, C double bond O, O negative, this is one electron is shifted here, one electron will be eliminated. So, you will have the formation of CH3, C double bond O free radical, right? Here is elimination of one electron. If you use two molecules here, there will be elimination of two electrons here, right? Then what will happen? Further, this will be cleaved. So here what you will have the formation of CH3 free radical, that is 2, and 2 carbon dioxide will be released here. And all of this is happening. Now tell me, at anode this is happening, because we know that anode in the electrolysis is positive. right? So an carbon ion will attack here, carbon ion reaction will take place here, right? Okay. Now CH3 and CH3 free radical, two free radicals will combine to give you CH3, CH3 and CH3. This is what we see at anode. Now at cathode, what is happening? See, at cathode, what is happening? You have H2. Let's say you have O, this is H, this is H, right? So H2, what will happen? This will again be cleaved here. You will have the formation of OH free radical and H free radical, right? So OH free radical, here you have 2 electrons in this system. It will gain 1 electron here and this will be converted to OH negative, right? With addition of 1 more electron here, right? And this, 2 of this will join together, that means 2H. There will be so many free radicals, H free radical here, and this will give you H2 free radical, H2 gas will be released. So what they can ask you, that at cathode what is formed? H2 is formed, H2 is liberated at cathode, carbon dioxide is liberated at anode, and alkane is formed at anode. And what is the medium? The medium is a basic medium. It is a basic medium, that you should remember. Okay, that you should remember. Right, okay guys? Okay, this is what they can ask you. What is formed at cathode? What is the medium? All these things. Okay? Yes, everybody? Acha. Now see, now they are saying that if you have hexane, in Cohen's electrolysis, what must be the acid that you must have used? So, acid will be double of the alkyl chain. Sorry, half of the alkyl chain. So, alkyl chain is 6 membered. So, this chain will be half of it, that means 3 membered. And here you will have COO negative Na. With the Cohen's electrolysis, you will have the formation of C6H14, that is hexane, right? But if you talk about same thing from soda lime decarboxylation, then you will have CH3, CH2, 1, 2, 3, 4, 5, 6, COO, COONA, and this is what you will have. Okay, COONA, and this is what you will have, right? So this, guys, this is actually Cohen's electrolysis, and this is soda lime. This is soda lime. Okay? Yes, everybody? Yes, everyone, do let me know if that is clear to all of you or not. If there is any problem, then do let me know. If there are any Hello, hello, hello. Hello, 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 hello. Guys, how this happened? Hello, hello, hello. I'm so sorry. So sorry. Achha, now tell me, is that okay? Is that okay? So sorry. So were you able to understand whatever I did, right? So what we did here, I was doing the same thing that we did in case of Wood's reaction. Make a free radical, combine it together, you will have RR. If free radical you have on one, you have two free radicals, then intra will be preferred. And if intra is not anti-aromatic, that will be preferred. Here, free radical, combine it together. Free radical, combine it together. Here, make a free radical. Intra is anti-aromatic, so you'll have to make inter product here. Okay? Yes. Abhigna, I'll talk to the team about it. Okay? You just write down your ID, right? What is the ID, right? I'll talk to the team why it is happening. Okay? Yes. Yes, everybody, tell me. Tell me. So you can send me on your Telegram, on my Telegram also you can send me, Abhigna, okay? Or what you do, wait a minute, what you do, on my Telegram, on my Telegram there is a section of comment as well, right? So you can write it down in the comment, your ID, then I'll immediately send it to the team and ask that what is the problem, okay? Yes? Okay, everybody. Now let's talk about next thing, that is alcoholic aldehyde ketone carboxylic acid. So when you use, reduction is done by using red phosphorus. So what will happen in that case, right? All will be reduced to alkene with the same number of carbons, whether you have alcohol or carboxylic acid or ketone or ester, right? This will be, yes, ketone, aldehyde ketone or carboxylic acid, all will be reduced to alkane with the same number of carbon using red phosphorus and HI, right? Now guys, let's talk about some more reactions. Let's talk about Clemenzin reduction, Wolff-Kishner reduction. Let's talk about that. From ketones, how it is formed. These questions, these reactions will again be repeated in the next class, in the upcoming lectures as well. So when you have ketones, what will happen if you have zinc amalgam in the acidic conditions? In the acidic conditions, this double bond O is directly converted to two hydrogens here, right? So directly alkane is formed here with the same number of carbons, but here it is zinc amalgam is used and it is in the acidic conditions. And then there is Wolff-Kishner reaction where we are using basic conditions here, right? Basic conditions, KOH, ethylene glycol, these basic conditions we have here. In these basic conditions, with the help of hydrazine, this double bond O is directly converted to, wait a minute, no, wait a minute, this is another reaction only, this is not correct, wait a minute, this will not happen here, right? Beta, see, this reaction is entirely different. If I don't use any of this, then this reaction will take place that we will do in aldehyde ketones. This is not this reaction, okay? So I'll just delete it. That reaction will do in aldehyde ketones, right? This reaction is when you have, this is R, this is R dash. So here what you will have directly when you use hydrazine in the basic conditions, right? That is directly converted to RCH2 R dash. That is formed here, right? Okay. Right? Yes, everybody. Tell me, is that clear? Is that clear, everybody? Happy Dussehra, happy Dussehra. Okay, now let's talk about some questions here. Let's do some questions here, guys. So, given below are two statements. This is JEE Mains 2023. Given below are two statements. One is labeled as assertion and the other is labeled as reason. This can be subjected to Wolff-Kishner reduction to give this compound. Okay. Wolff-Kishner reduction is used to convert this to this. So guys, let's see this condition. So Wolff-Kishner reduction occurs in the basic condition. So if you see any acid base sensitive group, then the reaction will be different. Okay. So if you see this here, then you have this thing, because this particular group is base sensitive group. In basic conditions, you have hydrazine here, you have basic conditions here, right? You have hydrazine, N2H4 is hydrazine. In the basic conditions, you use in Wolff-Kishner reduction. So what will happen here? This group is base sensitive. So what it will do? Cl will be eliminated here and H will be eliminated here. This bond will shift here. And rather than converting this double bond O to CH2, here this is converted to alkene. So that is why first statement is incorrect here. So A is false, R is right. So answer will be B is the correct answer. Similarly, in Clemmensen reduction, acid sensitive group should not be there. Acid sensitive like OH should not be there. OH is acid sensitive, right? So acid sensitive group should not be there. So this is what we need to know. Then guys, let's talk about Grignard reagent, how it is formed. So how the Grignard reagent is formed? Grignard reagent, guys, it is formed. Now we'll see. Firstly, Grignard reagent formation is there in haloalkanes, haloarenes as well. So because this is the first chapter of organic chemistry, proper reactions, that's why today everything will be new. But in the next lectures, you will see some reactions here and there will be repeated, right? Okay, that's how organic chemistry is interconnected. So you will have alkyl halide. So what will happen? This Mg will get in between and this will become RMgX. This is your Grignard reagent. This is called as Grignard reagent, which is organometallic compound. And in case of Grignard reagent, guys, always this is RMgX, this is RMgX. This is partially positive and this is partially negative. An organometallic compound is one of the rarest compounds in which carbon is having partially negative charge. Okay? Because metal is highly electropositive, so that's why carbon here has negative charge. Got it? Right? Okay? Oh God, Nandini, is it? Oh my God. Nandini thinks that ma'am has 3-4 eyes. Ma'am is teaching here also, and then ma'am is slightly looking at the comments also. Nandini, why so harsh in life? Huh? Why so harsh in life? How you get so much harshness? Right? I know you have never joined my class. These kids know that I never ignore them. Right? So relax. Right? Don't be so bitter in life. Right? Okay. Clemmensen and Wolff-Kishner is same but different. Yes, that is correct. Okay, ma'am, how to remember? I'm just keep on forgetting. Yeah, revision is the key. Revision is the key. Ma'am, acid base sensitive is bit confused. Beta, see, all you have to remember is in Clemmensen reduction, there should not be acidic sensitive group which can react with an acid, right? Which will react with an acid, like OH negative can react with an acid, right? So these are acid sensitive groups, right? Base sensitive groups like Cl is a base sensitive groups. Here you should not have base sensitive groups like Cl is a base sensitive group, right? Like CO negative is a base sensitive group. So base sensitive group should not be there, otherwise this reaction will not take place. Okay, yes everybody, tell me. Acha, tell me now about Grignard reagent. Is that clear that you have Rx with Mg, when you add Mg in the dry ether, right? You'll have the formation of Grignard reagent here, right? Okay. Ma'am, class 11 GOC when? Beta, I have done GOC already. I don't know which universe you are living in. I have already done GOC, right? We have done it in detail. So go and watch it. Achha, tell me, RMGX, is that clear to everybody? Is that clear to everybody? Okay, all clear, great. So, Grignard reagent shows two type of reactions, right? Let's see what are the two types. First is they react with, I'll just show here. First is they react with proton source to give alkane, and then they react with carbonyl group. How Grignard reagent reacts with carbonyl groups like this kind of compound, how they react with this, that we'll talk about in aldehyde ketones, even in alcohol phenols we'll talk about it, but in today's lecture we will not talk about that. Our focus is how Grignard reagent reacts to form alkane. Now Grignard reagent, here also we use dry ether here. Grignard reagent is totally psycho about one thing. Which is that one thing? He's like, I need proton. If anywhere it sees a proton source, so what can be that proton source? These proton source can be H2, it can be alkyne, because alkyne we will talk about later that how this hydrogen, in alkynes we will talk about how this hydrogen is quite acidic in nature. So any proton source you have, any base you have, right, because base is going to abstract the proton, any acid you have which is a proton source. So any proton source you have, right, it will abstract the proton from there and get converted to RH, that is the alkene. So it is crazy about one thing, that is a proton source. So if you see this here, RMGX, for example, this is a proton source, it will abstract the proton from here, it will get converted to RH, and here OHMGX, right, that will be formed, that means Mg, that will have X and that will have OH here. So that is how you will have the formation of alkane from the Grignard's reagent, okay. That is how you will have the formation of alkanes from the Grignard reagent. Okay, so these are the different proton source that can be there. Acids also you can include. Okay, now let's talk about physical properties of alkanes. Yes, everybody. Are you guys tired now? You guys are tired, is it? Tell me if you want to, like, how much time, how much capacity you have right now. Tell me, according to that I'll teach. Right? How much capacity is there? Praveen, this is what I told you, na beta, that's what I was telling you. Hai na? From there, how much request we have done to you. Right, that please guys be there in the class, right, because sometimes the things go beyond our hands, right. So all I can say is that now watch the lectures here, same content will be there, right, the syllabus is same, so watch it here. I am same, I am not different, right, syllabus is same, so watch it here, right. Okay, yes, right, yes. Okay, tell me. Acha, how many students are my regular students here? How many students here are my regular students? Write it down in the chat box. I want to see that. So there is some well-wisher of you, Nandini, out there. She is like very tense. She is like, forget about my studies. I am very tensed about other students. That ma'am don't care about students. Ma'am is not, ma'am don't listen to students only if students have understood or not. Tell her. Don't I listen to you guys? Don't I ask you again and again? Is that clear? Is that clear? Is that clear? Is that clear? Tell me. Is there any doubt? Tell. I don't want to reply her. You only reply her. Right? You only tell her how many times I ask you and what is my capability of answering your doubts. Right? You only answer her. Because these, no. Chalo, ignore that. Okay? Now, let's see. They will, when some teacher has live watching, 3,000 live watching, they will be like, they feel teachers are like, now this is what to do here. Education has become a business, right? Education has become a celebrity something or something like that it has become, right? So what to do, right? Earlier it was not used to be like that, but what to do, right? Students are like, oh, only this much live watching. Even if the content is good, I'll not watch it. I'll go and watch something where the live watching is better. You focus on the content, watch the lecture, score something, do something in your life, right? This bakar you're doing here, right? So, let's talk about properties of alkenes. Yes. Praveen, that's literally not in my hands. I can't say anything about it, okay? Yes. But I can't see your energies. Where is your energy? Where is the energy? Oof. Where is the energy? Done. I don't expect this kind of energy here. More energy I need. More enthu I need. Right? Otherwise, we'll do it tomorrow. No issues. Okay? We'll do it in tomorrow's lecture. If you're like exhausted, it's fine. You can tell me about it. Right? Yeah, that's true, Abhishek, that's true, right? I'm also, ma'am, Adipeva, yes, very good. So, how's the Josh, how's the energy, guys? Is it there or you're like, ma'am, sleeping, ma'am? Okay. So, physical properties of alkane, if I talk about, so when you talk about C1 to C4, it is gas, right? C5 to C17, it is liquid. C18 onwards, it is a solid. Usually these things they don't ask you, so just it is written in your book, that's why I am telling you this. Then density is mass by volume. Alkanes have less density than water. This is all you have to remember. That's it. Okay? Alkanes have less density. Then melting point, important. Melting point is directly proportional to the packing efficiency. So, packing efficiency of even number of carbon is more than odd number of carbon. So, we can say if you have C4 and C3, C4 will have more melting point, right? Because of even numbers, right? Okay. So, even numbers will always have more melting point as compared to odd numbers, because in the case of even numbers, the packing efficiency will be high as compared to the odd numbers, right? Okay, so that is going to be there. Then next is boiling point. Now let's talk about the boiling point, guys. Very important. Now this is one of the most important physical property. Boiling point and solubility are very important for every single functional group that we'll talk about. Now, boiling point is directly proportional to molecular weight and inversely to branching. That means if I say that butane is more or propane is more. So, more the number of carbons, more will be the boiling point, right? But when I talk about 1 degree, 2 degree, 3 degree, wait a minute. Let's say you have CH2, CH2, CH3, right? Here the branching is like this, 1, 2, 3, CH3, CH3, CH3. Now, which has more branching? This has more branching, So more the branching, less will be the boiling point. Less the branching, more will be the boiling point. So this is going to be the answer here. So that depends upon the branching and the number of carbons that you have. Okay, everybody. Now color and odor that you have. Okay, let's talk about color and odor. So first 4 alkanes from methane to butane are colorless and odorless gases, right? First four alkanes are colorless and odorless. Next 13 from pentane to heptadecane are colorless and odorless liquids. Firstly gases, then liquids, then solids. Rest of the higher alkanes having 18 carbons or more are colorless solids at normal temperature. Okay, so these are just theory points that these are factual things. Now solubility is very important, very, very important. Let's talk about this. What is solubility? So let's talk about this, everybody. End the session for today. Oh my God, Rama is fully drained. Okay. So now here if you see, alkane being non-polar molecule, right? Alkane being non-polar molecule, because guys there is no polarity difference here. Carbon and hydrogen don't have that much high difference in the polarity, are soluble in non-polar solvents like benzene, ether, chloroform. However, they are insoluble in polar solvents like water, because there is no hydrogen bonding that it is showing with water. So that's why it is insoluble in water. The solubility decreases with increase in their molecular weight. More is the molecular weight, the solubility is going to decrease in this case. So I will write just directly, solubility is inversely proportional to molecular weight. Okay. Okay, everybody, that is going to be there. Now let's talk about this question here, that is JEE Mains 2025 question that says, given below are two statements, neopentane forms only one monosubstituted derivative. Melting point of neopentane is higher than this. This one is actually depending upon properties also. Okay, chalo, let's see. Okay, neopentane means this thing, right? This is 2025 question, so it is, this is your neopentane, right? This is neopentane, right? So every hydrogen that will be substituted will be 3 degree. If you substitute this hydrogen or this hydrogen or this hydrogen or this hydrogen, they all are symmetrical. So that is true that neopentanes form only one monosubstituted derivative, that is true. Melting point of neopentane is higher. This has branching, and branching, more the branching, less is the melting point they are talking about, less is it. That means N-pentane will have it more, right? N-pentane will have more melting point as compared to neopentane. So that is false. So we can say first is correct, second is incorrect. So the answer is going to be melting point or boiling point they are asking you. Wait a minute. Melting, acha. They are asking you the melting point here, not the boiling point. So when you talk about the boiling point, then the boiling point of N-pentane, because of less branching, it will be more, right? But in case of, when we talk about the melting point depends upon the packing efficiency, right? So the packing efficiency of neopentane will be more as compared to N-pentane, right? So answer will be neopentane will have more melting point. So answer will be both the statements are the correct statements here, right? So B is the correct statement here. Now guys, next is chemical properties. So I just want to know if you guys are still up for chemical properties here or not, right? Okay. Do you want me to teach you chemical properties today? Because beta see, I want to complete this chapter in 3 days. if you don't do it today, then tomorrow you will have even longer chapters. So you can't run away from that. It's your choice what you want to do. I can teach you now also. It will not take much of time, hardly half an hour it will take us to complete chemical properties. Because the preparation was the lengthier one here. Rest of the things are not that lengthy. In chemical properties, most of the reactions are direct here. There is one reaction, that is halogenation reaction, that is in detail, right? So now let's talk about this, everybody. Acha, only one student. What about others? What about others? So 3-4 reactions I'll see. Even if you feel drained that way, then because beta tomorrow I want to finish alkene and alkynes, right? Alkene and 3 you can't finish tomorrow. That's not possible. Then don't ask me, ma'am, when you will complete the syllabus. Then if I keep it so slowly, then the syllabus will take around 2-3 months, right? So even I have to, right, give you more time, and even you have to invest in more time, right? Only then we will be able to match up to the deadline that we have decided, okay? So complete oxidation or combustion, that is endothermic reaction. That means we are saying that if combustion means to a hydrocarbon, when you provide oxygen and you heat it, the products are, wait a minute, combustion is not endothermic, this is exothermic. Wait a minute. Okay, this is exothermic, right? So combustion is exothermic in nature. So here heat will be evolved here, right? After that heat will be evolved here. In combustion reactions, heat are evolved, right? So due to evolution of large amount of heat during combustion reaction, they are used as fuels, right? So what will happen, you give it and you will have the formation of carbon dioxide and water and the elimination of heat here, right? So I'll give you direct mechanism. Either you can remember this one, or I would advise you to remember this one directly. Wait a minute. Yes. So you can remember this one. This is CnH2n. If this is N, this is a simple reaction which you have to remember. This is N, then this will be 2N plus 2 for alkane. This will be 3N plus 1 by 2 for O2. N amount of carbon dioxide and N plus 1 amount of H2O will be released here. This is useful in redox reactions, in equilibrium as well, right? In different physical chemistry also, this formula you will have to apply. If they ask you combustion in mole concept, this is used, right? Because sometimes we don't know the reaction of combustion. So this is a direct way of remembering. This is simple alkane formula, 3N plus 1 by 2. This is N, this is N minus 1. Here if it is alkene, this will be 3, instead of 3N plus 1 by 2, you are just writing 3N by 2. And here it is N, here also it is N. Now in case of alkyne, you will subtract 1 here, you will subtract 1 here, and that will be your answer. Okay, so alkyne formula, subtract 1 here, subtract 1 here, and that is your answer. Simple. Okay, so what we have done, alkane, whatever alkane it is, write the formula. Oxygen will be 3N plus 1 by 2, or 3N by 2, or 3N minus 1 by 2. This is for alkane, this is for alkene, this is for alkyne. Carbon dioxide is always N. Water is N plus 1 for alkane, N for alkene, N minus 1 for alkyne. Okay, tell me guys if that thing is clear. If that thing you have already learned, I think in between also you should remember this, right? See, what you have is Cn, this is for alkane, this is for alkene, this is for alkyne. Okay, yes. So here what you will do, how much oxygen you will use? This will be 3n by 2, right? 3n by 2, right? 3n by 2, right? 3n by 2, this should be -1, this should be 3n oxygen, this should be this should be +1, because it is +2, it will be +1, it is -2, it is -1. Okay. About carbon dioxide, it is always NCO2, NCO2, NCO2. And what about water? This is N+1 water, because this is +1 in the formula. This is N water, this is N water, and this will be N-1 water. Okay, this is how you remember all of them together. Okay, I retract, very good, very good, good. Right, you must, even my energy is little bit low, but you know, you have to go beyond that, you have to push your limits. Only then you will be able to make it, if you push your limits. Right, okay, yes. So wait a minute. Okay. So here what we have, actually I was just messaging my mom that she should sleep, because she always waits for me. So I was just texting her that please sleep, right? So incomplete oxidation, right? My mom is also sacrificing for you guys, also waiting outside. So I can give you 2-minute break and tell her to sleep, right? Incomplete combustion of alkenes with insufficient amount of air or oxygen forms carbon black, right? If there is incomplete combustion, then you will have the formation of carbon black here. Simple carbon will be formed here. Okay? Yes, everybody? Chalo. Just give me a second. I'll just ask her to sleep and say good night. Just give me a minute. Moms being moms, right? She was waiting for me outside, right? So, yes. So if you talk about incomplete combustion, right? Incomplete combustion means no sufficient supply of oxygen is there. So in that case, carbon black will be formed, right? Not carbon dioxide, carbon black will be formed. So what about controlled oxidation? When you specifically you want to form something, like you want to form methanol. So what you do here, these are from your NCERT only, I think directly, or this is from Tattva, right? So this is, I think this is there in NCERT as well here. This is alkane with methane. If you give O2, copper at 523 Kelvin, 100 atmospheric, you will have the formation of methanol, right? If you have methane with oxygen and you use molybdenum oxide, this is MO2O3, molybdenum oxide you use here, then you will have the formation of methanol here. This is methanol that you have here. Okay, methanol and methanol, that is called as controlled oxidation. Then when you use ethane, right, and you use oxygen, but here you are using manganese acetate. Manganese acetate, you have the formation of ethanoic acid, right? These three reactions are some different reactions that you should remember, that is under the part of controlled oxidation. Methane with O2, when you use copper, it is methanol is formed. When you use molybdenum oxide, aldehyde is formed, that is methanol is formed here. And when you use in ethane, you use oxygen and you add here manganese acetate, then you have the formation of corresponding same number of carbon carboxyl. Don't remember ethanol, methanol, just remember alcohol, aldehyde and carboxylic acid is used. That's how you have the chapters, right? Alcohol, then you have aldehyde, then you have carboxylic acid. So that's how you can remember. Okay. Now next is potassium permanganate readily oxidizes to a tertiary hydrogen atom. That means readily oxidizes a tertiary hydrogen atom, that is this one, to hydroxyl group. For example, you have this thing. You have this thing. This is CH3, 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 and this is hydrogen. So what is a tertiary hydrogen? Tertiary hydrogen is that hydrogen which is connected to a carbon which is further connected to 3 more carbons. What is a primary hydrogen? That hydrogen, if it is connected to a carbon which is only connected to 1 more carbon. What is secondary hydrogen? Hydrogen which is connected to that carbon which is further connected to 2 more carbons. What is tertiary? When it is further connected to 3 more carbons. So here this is a tertiary, this is a 3 degree hydrogen. So when you have potassium permanganate, this 3 degree carbon is converted to OH. So this will be converted to C, this is CH3, this is CH3, this is CH3, and here it is connected to OH. So that is the answer that you will have here. Tell me if that is clear, right? Yes, yes, you have to remember all the reactions. That's why I am saying that, you know, things you have to revise again and again. So that's why I am taking lectures will be now longer. You can't expect me to complete the syllabus by ma'am 1.5 ma'am maximum I can study. No, you are preparing for JEE. This is minimum that you can do, right? So halogenation reaction, now this is one of the most important reactions. Mark it very, very important. Please have full focus here, guys. This is very important. I am not going to repeat it in haloalkanes, haloarenes. Today I am doing it not in, I'll just directly tell you this we did in hydrocarbons. Okay. So halogenation reaction, that means what you do to any alkane, you add halogen in presence of light and you will have the formation of corresponding alkyl halide. And this is going to follow a free radical mechanism. Let's see how. This is the question that, okay, H mu or free. Now free radical mechanism is basically done HELPR. HELPR, helper. Just remember helper. If there is heat or there is electricity, like in coal electrolysis you have electricity, right? If you have electricity, if you had light, UV light or H mu, which is a light, or you have peroxide, or you already have a radical that is present. In all these cases, free radical mechanism will be followed. Okay. So here what can happen? Again, this one, what is the reaction that can take place? You have one hydrogen will be replaced. Then another hydrogen will be replaced, you will have CH2Cl2. One more hydrogen is replaced, you will have CHCl3. One more hydrogen is replaced, you have CCl4. Right? This is the reaction that it can show. Now ma'am, what is exactly the mechanism? Let's talk about that. Mechanism is that in this case, free radical mechanism is used. Right? So 3 steps. First is the initiation step, in which by homolytic cleavage, that means this will shift here, and you will have the formation of 2 Cl free radicals. and this will release the energy. That means this is an exothermic reaction, right, of fluorine molecule in the presence of sunlight. CCl bond is weaker than CC and CH bond. That is the reason in the initial step CCl bond will break, not CC or CH. CCl bond will break because this is the weakest bond here because of very high electronegativity here, right. After this, initiation by this fluorine molecule made the presence of sunlight. CCl bond is weaker than this. Acha, this so we repeat it. Wait a minute. Acha, that is repeated. Okay. Second one is chain propagation. This is the second step here. This was the first step and this is the second step, that is chain propagation. So in this case, you will have a Cl free radical and you will have this again homolytic. I told you either you should have heat or electricity. You will have a formation of free radical. Once you have free radical, further more free radical will be formed here. So this will form H free radical, this is Cl free radical, this is CH free radical. These will combine together to form HCl, right? And HCl and Cl3 free radical will be formed here, right? Okay. Now, here energy is required, है ना? Here energy is required in this process. In this step, energy will be taken by heat, electricity or whatsoever. In the second step, it will start releasing the energy. Now propagation is there, right? Now this CH3 free radical, again this one molecule will break to give Cl free radical and hence you will have the formation of CH3Cl, okay? Now in the third step, in the termination step, all the free radicals will combine. In the solution, you can have Cl free radical which will combine Cl2. CH3 free radical, they can give you RR here. CH3Cl free radical can give you RCl. So these are all the different kind of products that can be formed. The formation of ethane as a byproduct during chlorination of methane is also possible here, right? Possible chain termination steps. So all these are your possible byproducts, right? Now this is one of the most important things. From mechanism, free radical, they will not ask you what is initiation, propagation. You should know that, right? From here the questions are asked, okay? Based on the product, they ask you the questions that what will be the product. Based on this is where you have to give full focus. So this thing to even board students know that, okay, this is the thing. It's not like important for JEE, this thing is important for JEE, right? So what you need to, everything is important, this thing is more important, right? So here one, you should know that the reactivities are F2Cl2Br2I2. This is very slow, so we'll not talk about I2. This is very fast, that it is very explosive in nature. It is so fast that it becomes explosive for us. So it is so explosive that we don't want to talk about it only. It is so explosive. We don't want to talk about it. So we are only focusing on Cl2 and Br2, right? So if you see around you, there are people who are very reactive and the people who are very selective, right? There are people who will choose one thing and they will say, this is the thing that I want. They will not think about anything else. They are very highly reactive. They are not choosy, right? They will go to a shop and they will be like, okay, this one dress I really like, I'll just purchase it. They will not look for any other option, right? They are very highly reactive, right? And then there are selectivity, that is about bromine. It is highly selective, right? So let's talk about reactivity, selectivity of chlorine and bromine. So if you talk about reactivity, selectivity, right? Wait a minute. Why reactivity, selectivity we are doing? Because if you have this kind of question, you can replace this hydrogen, you can replace this hydrogen, this hydrogen, this hydrogen, this hydrogen, this hydrogen. So which hydrogen will be replaced? That is the question, okay? Because of that reason, we are using reactivity, selectivity principle. It says that this is the probability factor that I have written here. So when you have chlorine, for 3 degree hydrogen, 2 degree hydrogen and 1 degree hydrogen, you will multiply to get the, which will have the highest rate, you will have to multiply with these numbers. For 3 degree hydrogen, you multiply by 5, for 2 degree with 3.8, for 1 degree it is 1. In case of bromine, it is 1600, it is 82 and it is 1. Bromine is highly selective. Can you see that it is so selective? Bromine is like, no matter, it's like today, now we have festive season, like festive sales, right? What actually we do, sometimes we are like, okay, I have choose this thing, right? No matter I am getting it for less cost, I'll go for this one only because that is worth it. Like you have our test series, right? You know that it is worth it, so you will go for that thing, right? Very highly selective you are. So selectivity will be defined by this factor. So in case of bromine, always you will have 3 degree, then 2 degree, then 1 degree. 3 degree hydrogen will be replaced, then 2 degree, then you will have 1 degree. This is the selectivity. Bromine does not need all these things. It is like, I am so selective, I have 600 for 3 degree hydrogen. The affinity for 3 degree hydrogen is maximum. But in chlorine, the difference is very less, right? That's why in chlorine, they ask you the questions, right? In chlorine, answer can change at any point. 5, 3.81, just remember this. Now I'll tell you how to answer it, okay? So firstly, guys, you will have to remember how many 1 degree, 2 degree or 3 degree hydrogens you have. These hydrogens, if you see, I'll just draw it. If you see here, CH3, CH2, CH3 it is, no? So I'll just draw here. 1, 2, 3, this is H, 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 then H, H, H and H. Now guys, if you see this here, right, this particular carbon is very important, right? This hydrogen is connected to that carbon which is further connected to only one. So these that I am marking by red, they are primary. They all are primary. And this that I am marking by blue is secondary. How? Because this hydrogen is connected to that carbon which is only connected to 2 more carbons. So these are 2 degree and this is 1 degree. These are 1 degree. So how many 1 degree and 2 degree? Let's write. How many 2 degree hydrogens you have? You have total 2 degree hydrogens. And what is the factor of 2 degree? 3.8. So you'll multiply it by 3.8 and what you will get around 7.6. Right? This you will get. How many 3 degree you have? How many 3 degree you have? 1, 2, 3. Sorry. How many 1 degree you have? 3 degree you have 0. No 3 degrees there. 1, 2, 3, 4, 5, 6. 6. This is multiplied by 1, it will give you 6. So that means, can I say this factor is more? So 2 degree will be replaced here as compared to 1 degree. So answer here will be, when you replace it, 2 degree will be replaced. So answer here will be CH3, CCl, H and CH3. That is the major product. That is the major product that you will have. And minor product will be CH2Cl, CH2CH3. Replacement of 1 degree hydrogen will be the minor product here. It will be there, but it is minor product. It is there in JEE Advanced. Okay. Okay. Now let's talk about, okay, this we have already discussed that major will be formed. That is 2 degree will be formed. Now bromination we don't even have to think. Always it is 3 degree, then 2 degree, it is 1 degree. So 2 degree is chosen here. So answer for bromination is going to be, you will have CH3, CH, Br and this is CH3. That is a major product in case of bromination. You don't even have to think about it. Next question guys, let's talk about this one. If you see this one here, Let's firstly see which is 2 degree, which is 3 degree. This hydrogen is connected to that carbon which is connected to only one. This is 1 degree hydrogen. It is carbon connected to 2 carbon. This is 2 degree. This carbon is connected to 3 carbon, so it is 3 degree. This carbon is connected to 1 carbon, so it is 1 degree. It is 1 degree. So how many 1 degree, how many 2 degree, how many 3 degree you have? Do you have 3 degree? 1 degree is 3. How many hydrogen of 1 degree? 3, 4, 5, 6, 7, 8, 9. 9 carbons, 9 hydrogens. 2 degree, how many have? 2 degree, how many? 2 hydrogens that are connected to 2 degree carbon. So you will have 2. And 3 degree, you have only 1. Multiplication factor, here it is 1, here it is 3.8, and here it is 6. Here answer will be 6, here it will be 7.6, so here it will be 9. Can you see that? In case of chlorination, it's not 3 degree here. It is primary that will be replaced here. So here in this case, the answer will be primary here. The maximum number is of primary, so primary any this one or that one will be replaced here. So primary will be replaced. This is CH2Cl, CH2, right? CH, CH3 and CH3, that will be your answer. Or this primary also can be replaced. So it can be also CH3 because both are primary only. So CH, this will be CH2Cl and this will be CH3. So these two can be your answers. Yes guys, tell me if that is clear to all of you or not. Why 1 you are saying for this one? How many 1 degree you have? 3, 4, 5, 6, 7, 8, 9. Right? So you have 9 1 degree. So 9 multiplied 1 is 9. So primary will be replaced here. Okay. Yes, everybody, do let me know if that is clear to all of you or not. In case of bromination, it is always 3 degree. It is always 3, then 2, then 1. So always the case of bromination, you don't have to think about it. Just directly replace bromine with hydrogen with, bromine with 3 degree hydrogen. Okay, this will be the answer. Right, everybody? Do let me know, is that clear? 9, okay ma'am, done. Now very fastly we will do the rest of the reactions, very simple direct reactions, very rarely asked reactions, right? The thing that I don't give that much focus, you understand, learn something from bromine. Yes, chlorine should learn, right? Chlorine is not at all selective. Right? Chlorine is like highly reactive whatsoever, which is more I'll go there, right? Which is more I'll go there, right? It's not selective. Selective is I'll go into IIT only, I'll go into NITs, I'll go into good colleges. Which is more, I'll go there. Whatever I get, I'll go there. Chlorine is like that, right? Okay. Primary, 9 hydrogens I have, so I'll look for this one, right? So it is not very highly reactive, it is. Now let's talk about the nitration. Simple. HNO3 you have, H2SO4 you have. So what you will have, NO2 positive electrophile will be generated, that will replace this hydrogen here, and you will have the formation of nitroalkane in this case from the alkane. Next is, if you have directly oleum or concentrated H2SO4, this hydrogen will be replaced by SO3H here, right? This way aromatic reactions are more important. These reactions are not that important. Aromatic reactions will be more important. Now this is one of the most important reactions. Can you name this? This is Reed's reaction. Reed's reaction. This thing that you use here is sulfuryl chloride. I know you are getting confused. There is also one reaction that is ROH and you use SOCl2 and you have the formation of RCl, SO2 and HCl. That is called Darson reaction. That is Darson reaction. And this thing that we use there is thionyl chloride. Thionyl chloride we use there. Here we are using sulfuryl chloride. Okay, what we are using here? we are using sulfuryl chloride. Okay, so that is here we are using alcohol, here we are using alkene. So remember the difference. In case of alkane to alkyl halide, we use sulfuryl SO2Cl2, and that is called Reed's reaction. Okay. Then aromatization reaction. This is one of the most important reactions, guys. Mark it, very important. These reactions you should remember directly. This is actually a very important reaction that they ask you, right? Okay. Yes. Ask what is your, yes, you can ask this, you can definitely watch this, you can definitely watch this. Okay, yes, everybody, but don't spam her, right? So this reaction is known as aromatization reaction. You have a simple open chain here with the use of Cr2O3 or vanadium oxide or molybdenum oxide at a very high temperature, that is 773 Kelvin. With the same number of carbon, you will have the formation of aromatic compound. Like from cyclohexane, this is a very important reaction, guys, very important reaction. When we will do series of reactions after completing like all the chapters, I'll conduct a question answer series. See, organic chemistry now, I'll tell you, in organic chemistry there is no point of me doing question answers if I have not completed all the chapters, right? Okay, so that's why they are connected to each other. That it means in one question they will ask you from different chapters, right? So maybe from haloalkanes to alcohol to aldehyde, they will mix all the chapters. That's why I'll conduct the sessions for questions as well, but once we have done everything. And this particular reaction is very important in that in cyclohexane with any of this reagent, directly benzene is formed, directly aromatic compound is formed here, right? Like in N-octane, if you have 8 number of carbons, 8 carbons, directly you have the formation of orthoxylene or ethyl benzene. These two can be formed here. Any of these two can be formed here, right? Okay. Then there is a reaction with benzene. So if you talk about, right, if your methane reacts with steam, wait a minute, this should be H2O. That is H2O, right? So here you have H2O. Methane with H2O and nickel and heat will give you carbon monoxide and H2. Methane reacts with steam. We are saying methane reacts with steam and this much. In the presence, at a very high temperature, in the presence of nickel catalyst to form carbon monoxide and hydrogen, that is formed here. When methane reacts with steam, this water is in the form of a steam here, right? So carbon monoxide, this is one of the process of making carbon monoxide, right? And you know what is this called, right? This carbon monoxide and H2 is called as water gas, okay? This is called as water gas. CO plus H2 is called as water gas. Like CO plus N2 is called as producer gas. So they can ask you how water gas is formed. Methane plus steam will give you water gas, okay? Then pyrolysis, just go through this. What is pyrolysis? You will have any alkane, it will break down into n number of more alkanes. For example, you have any compound like this. It will break down into, maybe this bond can break, this will 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 break. All the compounds, all the bonds may or may not break, and any number of compounds will be formed here. So the alkanes on heating under very high temperature in absence of air are broken down into lower alkenes or hydrogen. Decomposition of compounds by heat is called as pyrolysis, right? For example, you have C6H14. So many numbers, this you don't have to remember, just remember that n numbers, so many numbers of different alkane, alkene, hydrogen, all these can be eliminated, right? The rupture of CH bond is catalyzed by oxide like chromium, vanadium, molybdenum, etc., the rupture of CC bond is catalyzed by silica, alumina and zinc oxide. Okay? Yes, everybody? Chalo, I think we have done it. I think only one question we are left with and that's it. Okay, so JEE 2022 question, that is a compound A on reaction with X and Y produces the same major product but different byproduct A and B. Different byproduct A and B is formed. Oxidation of A gives substance produced by ants. Okay, oxidation of A. Ants, some acid they will produce. Okay, so let's see, a compound A on reaction with X and Y produces the same major products. Okay, same major products. Wait a minute, guys. So this is not, this will not do here. Wait a minute. This though is not here, will not do it here. Wait a minute. That is actually in alkenes. Okay, that is ozonolysis of alkenes. That we will see in the next class. Okay. By mistake, I think the question, because I was thinking of doing alkene as well today. I think by mistake it is here. Right, we'll do it in the next class. So, this is your homework, guys. In the given compound, the number of 2-degree carbon atom you have to find out. How many 2-degree carbon atoms you have. And this is your homework, JEE Mains 2024. This is where they have asked this question, surprisingly. Right? Take a screenshot and give me the answer 2, 3, 4, 1. Which of the following is the correct answer? In the comment section, guys, you have to write it down, right? And guys, for more practice, right, we have launched a test series for you where we are providing you 93 topic-wise tests, right? From October to November, you can do that. Then part syllabus test by November end, you will, by November mid also, you will be able to complete your syllabus. It's not like now it will not be provided, they will be provided now only. You can give part syllabus now also, this is just a way of doing it. Part syllabus you can do, 11 part syllabus tests will be provided to you, 25 full syllabus, full length tests will be provided to you that you should do. Right? Okay? Yes, Ramaraj, I'll do that. Okay? So guys, right now this is at a price of 999, right? The offer has been extended just for you. So if you have not grabbed the offer, do it right away because the price is going to go anytime soon. So this is right now at 999 and hurry up, guys. Don't waste your time now, right? Link is in the description. Go and do that, right? Okay. So now I'll wait for everyone to write down their comments and let's see how many of you do your homework. Okay. Now tomorrow's class I'll tell you in the Telegram channel when I'll take the class. I think around 4 PM I'll take the class, but I'll see. Okay, because 4 to if it is at 8, I'll see that whether it's I'll take it at 4. I'll ask if there is any other class. I'll ask them to replace it. Right? Yes. Chalo. Basic strength PDF. Acha, I think the sessions that I have not taken on Studio, that PDF is not provided. Okay. Chalo, I'll do that. Okay? Okay. Okay then, guys. Bye bye. Take care. See you all in the next class. Bye bye. And happy Dussehra, everybody. Happy Dussehra. And take care of yourself. Utilize this holiday in doing something good. Till then, bye bye.